ladies and gentlemen. So today we're going to be talking about something called scientific notation. And this is where we're going to put together what we've been working on with magnitude and powers of 10, and we're going to put it together into the same, into one thing here. So when we look at this, we have this number, 234.567, and that's actually equal to all of these different numbers here. And all of these numbers are written as a number times some power of 10. Okay, but only one of these is the correct scientific notation, and that's this first one, right? So this is correct notation. Okay, again, they're all equal to each other. They all have the same value, but only this one is the correct notation. And here's why. We're going to actually kind of combine these two parts here together. A number in scientific notation has three parts. It has a number between 1 and 10. And you'll notice it says that up here. The number out front has to be bigger than 1 or equal to 1, but less than 10. And if it's equal to 10, it's too big. Then it has to have times 10. And this is one of the few times where it's okay to use an x for multiplication. And then it's going to have an exponent. So when we look at these, though the examples up top here, they all have a number times 10 and they have an exponent. But only this one is between 1 and 10. Right here we have 234, that's too big. Here we have 0.23, too little. Here we have 234, too big. All right, 23, too big. This one is way too big. All right, so that's what we're going to be looking at here. So first we just have to recognize, are they in correct scientific notation? So when I look at this, I'm looking for those three parts. So here I have a number out front. It is between 1 and 10, so that's okay. Then we have times 10, and then we have an exponent. So this is yes. All right, number 2. I have a number out front. It's between 1 and 10. Beautiful. I have 10 and an exponent. But I have an addition sign. And it can't be an addition sign. It has to be a multiplication. So this is no, should be multiplication, not addition. Okay, let's take a look at this one, number 3. I have a number out front, but it is not between 1 and 10. So this is a no. 0.325 is too small in this case. Okay, let's take a look at over here. I have a number out front, not between 1 and 10. So this is a no. But if I continue looking, we also have a problem here. This is supposed to say no, not, I don't know, whatever that is. Let's try that again. So this is a no. All right. 18 is too big. And the base is 5, not 10. Okay, next one. So here I have a number out front. It's between 1 and 10. That's good. I have a times, and I have a base of 10 to some exponent. So this one is in correct scientific notation. Number 6, I have a number out front. It's between 1 and 10. I have the time symbol, and I have 10. This time I have a negative exponent, but that's okay. So this one is also correct scientific notation. All right, let's see what else we have to do. So now we're going to take and actually try to write these in scientific notation. And we did this a little bit, right? We already did this. So when I take these numbers, it's going to be this number here, 4, times what power of 10 do I need? Well, that's where you count your decimal places. So I have 1, 2, 3, 4, 5, 6, 7 decimal places, 10 to the 7th. For number 8, right, and if you want to think of it a different way, you're moving your decimal from the end to after that first number. So this is going to be 7.32 times, and I'm looking, well, how many numbers are after that first digit? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10 to the 11th power. Number 9, 8.04 times 10, and then I have 1, 2, 3, 4, 5, 6, 10 to the 6th. 3 trillion, well 3 trillion looks like this. So that means I'm going to have 3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 power. So it's not the number of zeros, it's the number of, actually that's billion, not trillion. That's trillion. So let's fix that one. That means this is going to be to the 12th power. 8.5 billion, which means you have 8.5. So that's going to be 8.5 times 10 to the 9th. If you have a decimal, right, we did this earlier. If I have a decimal, then that means that I'm going from here to the end, 7 times 10, and my exponent's going to be negative, because negative exponents give me decimals. 1, 2, 3, 4, 5, negative fifth. For number 13, I'm going to go from the decimal to in between, 4.3 times 10, 1, 2, 3, 4, 5, 6, 7, negative 7. I'm going to go from here to right after the 2, 2.65 times 10 to the negative third. This is really looks like this. So we're going to have 7 times 10 to the negative 6. Okay, write the following values in standard form. So your exponent tells you the number of decimal places. That's what that tells you. So this means I'm going to take 5, and I have to move my decimal 6 places. So I have to go here, 1, 2, 3, 4, 5, 6. For number 7, I have to go 3 places. So here's 4.6. If I go 3 places, it's really going to be 4,600. 9.25 to the 8th, so we're going to have 9, 2, 5, so I have to go 8 places, 1, 2, 3, 4, 5, 6. Sorry, which is going to look like this. Negative exponents mean I'm going to go the other way. So this time I'm going to go to the left. So that's going to be 0.012. I'm going to go to the left 6 places. So that's 1, 2, 3, 4, 5, 308. And I'm going to go 1 place, 0.8325. All right, write the number in words. So I'm not sure what they want here. So I would read this as 6.3 times 10 to the 8th. And this is 3 times 10 to the negative 4th. Said in words, not symbols. Any questions? As always, bring them to class. Have a good night, guys.